A uniform solid sphere rolls on a horizontal surface at 20 meters per second and then rolls up a 30-degree incline. Friction losses are negligible. What will be the value of the height h where the ball steps to two significant figures? So let's see the diagrammatic representation of the information we have. Well, we have got this sphere which is rolling, going forward at 20 meters per second. It reaches a certain point where it has to climb a 30-degree incline, like that. Now as it starts to go up, the sphere will continue going up. Okay, it reaches a certain point where it can no longer go up, it will have to start going down. So at this point, what to be the height h? Of course it traveled a certain distance as from the beginning of the incline to that point. Now my own interest is only in the height. Now what do we need to understand here? Well, one thing to note is that there is both translational motion and rotation motion. It means as the sphere is moving, it is not just moving, it is also rolling. So there is a combination of linear and also angular motion here. And if it reaches at this point here, it is still having 20 meters per second velocity, but at this point, what kind of energy does it possess? Notice that it was rolling, so because it is moving at a certain velocity, it has got kinetic energy. Apart from kinetic energy, it is also rolling, it has got also rotation kinetic energy. So the rotation kinetic energy and the kinetic energy, by the time it reaches the maximum height here, they are all going to be converted to potential energy. Why? Because it will stop moving, it will stop rolling at this point. When it reaches this height, it will have to start going back. But how do we find kinetic energy? Kinetic energy is given by half mass times velocity squared. And how do we find rotational kinetic energy? Well, it is simply the same as kinetic energy, but in angular terms. Mass in angular terms is called the moment of inertia, I, and velocity, that would be the angular velocity, omega squared. And potential energy is given by mass times gravity times height. Now we don't know the moment of inertia, we don't know the angular speed, so we need to substitute this. So the moment of inertia for a sphere, this is the constant value. For a sphere, it is always 2 over 5 m r squared. That is how you determine the moment of inertia. But we know that whenever we're talking about linear speed, it is always the radius times the angular speed. Anything linear is just radius times the angular term. So this becomes half mass times velocity squared plus half. Where there is the moment of inertia, we substitute 2 over 5 mass radius squared. Where there is omega, we can make omega a subject of formula that will be v over r. So that becomes v over r, but we are squaring this, and that should be equal to mgh. And so this will give us half mv squared plus, these two can cancel out with that 2, so we're going to remain with 1 over 5 mass. Well, if we square this radius, notice that the speed here is going to be squared, the radius is also going to be squared, and then this 2 is going to go. We are distributing that square, so this square or radius squared will cancel with the radius squared there, so just remain with mass and then velocity squared, and that is going to be equal to mgh. Now another thing here is that mass is common for everything, so mass cancels in everything, so it's not dependent on the mass. So we just remain with half velocity squared plus velocity squared, and that is equal to gh. Now what is half velocity squared plus velocity squared? That is going to be 3/2 velocity squared, and that will be equal to gh. Alright, now actually this is not just velocity, I left out a 1/5, so supposed to be plus 1/5 velocity squared, and that is equal to gh. Now 1/2 plus 1/5, that is going to give us 7/10, and then v squared, it should be equal to gh. Remember, we want to calculate the height, you can divide both sides by g, so let me remove just some space there. So that will leave us with height being equal to 7v squared divided by 10g. Alright, now that we have got this, the height is going to be equal to 7, where there is velocity we know is 20 squared, divided by 10, where there is g we know that is 9.8. So the height is going to be equal to 7 multiplied by 20 squared, then divided by 10 times 9.8, which is 98. So that is 28.57. Now I want to give our answer correct to two significant figures. So this and this, we're going to remove a 1 from here and put there. So the height is simply going to be 29 meters. And that marks the end of this video. If that was helpful, be sure to subscribe. Stay blessed.